Hello students, welcome to my video. Hope you and your family members are safe at home in this lockdown crisis. Today in this video we are going to start the first chapter, rational numbers. Just recollect what you have learned in last year and all about number system, natural numbers, whole numbers and integers. Just recollect your previous knowledge about number system. Number system starts with natural numbers. Natural numbers are counting numbers represented by capital letter N. N is from the starting letter of natural numbers. So N is equal to, it starts from 1 to infinity. So set 1, 2, 3, etc. infinity. Next comes whole numbers. Whole numbers represented by W, which is the first letter of whole W. It starts from 0 to infinity. See the difference here. From natural numbers and whole numbers, only 0 is there extra in whole numbers. Remaining all counting numbers are there in whole numbers. Next comes integers, which is represented by the letter Z, which has come from German word Zahlen. Integers are negative numbers, 0 and positive numbers. So that is Z is equal to, negative numbers will extend left side and positive numbers will extend right side. So Z is equal to set etc. negative 1, 0, 1, 2, etc. Next comes rational numbers. Rational numbers are numbers which can be expressed in P by Q form, where Q is not equal to 0 and P and Q are integers. Example, 2 by 3, 1 by 5, any fraction you can write. Whether 0 is a rational number or not. Yes, 0 is a rational number since 0 can be written as 0 by any number. 0 by 1 is also 0, 0 by 7 is equal to 0. So 0 can be written as 0 by any number. Then it can be written in P by Q form. So 0 is a rational number. Now see the condition, Q not equal to 0. If Q becomes 0, P by Q form will become a number divided by 0. Any number divided by 0, that is 5 divided by 0, is not defined. Not defined, we will represent it as infinity. So any number divided by 0 is not defined, which is represented by infinity. Next topic is properties of rational numbers. You have already learned the properties of integers, natural numbers and whole numbers. All properties we have to check for the 4 fundamental operations: addition, subtraction, multiplication and division. So first property is closure property. Closure property. Can you say what is closure property? Closure property means if A and B, small letter A and B, are any rational numbers, we will represent it as belongs to. This is the symbol for belongs to. Belongs to. If A, B belongs to rational number is represented by Q, which has come from quotient. So A and B, if they represent quotient, that is rational number, then A plus B also a rational number. If A and B are any two rational numbers, then A plus B, this is for addition I am saying, A plus B is equal to a rational number. For subtraction, you have to check A minus B whether it is a rational number. For multiplication, you have to check A into B is a rational number or not. And for division, you have to check A divided by B whether it is a rational number. So first we will check additions. Take example, let A is equal to 1 by 3 and B is equal to 2 by 3. Add that A plus B is equal to 1 by 3 plus 2 by 3, which is 3 by 3. 3 by 3 you can write it as 1. So 1 is definitely a rational number, or 3 by 3 also is a rational number. So that means A and B are rational numbers, then A plus B also is a rational number. That is, we can say that rational numbers are closed under addition. Rational numbers are closed under addition. Which is nothing but closure property is satisfied for addition of rational numbers. Next we will check subtraction. For subtraction, we have to check that whether if A and B are rational numbers, then A minus B is a rational number or not. If A minus B is a rational number, then we can say that subtraction also is true for closure property. Let us take A is equal to 3 by 5 and B is equal to 1 by 5. So A minus B equals 3 by 5 minus 1 by 5, which is equal to 2 by 5. Obviously 2 by 5 is a rational number. So A and B are rational numbers, then A minus B is also a rational number. That means rational numbers are closed under subtraction also. Now we will check for multiplication, third fundamental operation, which is multiplication. For multiplication, A into B, if A and B are any two rational numbers, then A into B is a rational number. You have to check. If it is a rational number, we can say that it is true for multiplication also. Closure property is true for multiplication also. That is, let us take the example, A is equal to minus 2 by 5. Negative numbers also rational numbers only. And B is equal to 3 by 4. So A into B equals minus 2 by 5 into 3 by 4, which is equal to minus 6 by 5 into 4, 20. Obviously, minus 6 by 20 also is a rational number. So that means rational numbers are closed under multiplication also. Next we will check for division of rational numbers. That means if A and B are any two rational numbers, A divided by B should be a rational number. If it is a rational number, then we can say that division also is closed under addition. If it is not a rational number, then we have to say that it is not closed under division. So we can take one example. Let A is equal to 3 by 5 and B is equal to 2 by 7. So A divided by B, that means 3 by 5 divided by 2 by 7, which is equal to 3 by 5. Division will change to multiplication and take the reciprocal of the second number. Reciprocal means ulta you should write. Numerator will become denominator and denominator will become numerator. That is 3 4s are 21 divided by 5 2s are 10. Obviously 21 by 10 is a rational number. But if the second number, that is B is equal to 0, then a divided by b means a divided by 0. Any number divided by 0, again it is not defined. So that means when 0 comes, this is not true. If any one number a divided by b is not a rational number, then we have to conclude that division is not satisfied here for closure property of rational numbers, or you can say that rational numbers are not closed under division. So it is closure property satisfied for addition, subtraction, multiplication, but not division. Second property is commutative property. Commutative property. Commutative property means order change. For addition, a plus b, if a and b are any two rational numbers, then a plus b equals b plus a. Position of a and b are interchanged here. For multiplication, when it comes, a into b equals b into a. You have to check that. For subtraction, a minus b equals b minus a, you should check. And for division, a divided by b equals b divided by a. If it's satisfied, commutative property is satisfied for rational numbers. We will check one by one. First for addition. Take two examples. Let a is equal to 1 by 3 and b is equal to 2 by 3. What is a plus b? A plus b is 1 by 3 plus 2 by 3, which is equal to, since denominators are same, you can write like this and add the numerators. So which is 3 by 3. You can write it as 1. And now we will check it, b plus a. So b is 2 by 3, interchange the positions, 2 by 3 plus 1 by 3 equals, again denominators are same, so add the numerators, that is 3 by 3, which is equal to 1. Since a plus b is equal to b plus a, we can say that addition is commutative for rational numbers. So addition is commutative for rational numbers. Now same way we have to check for subtraction. Subtraction, you have to check whether a minus b is equal to b minus a. We will take one example. Let a is equal to 2 by 4 and b is equal to 1 by 4. So a minus b equals 2 by 4 minus 1 by 4, which is 2 minus 1, 1 by 4. Now next check b minus a. Change the position, 1 by 4 minus 2 by 4, which is equal to 1 minus 2 is negative 1 by 4. Obviously 1 by 4 is not equal to minus 1 by 4. So that means a minus b not equal to b minus a. Or what you can conclude? Subtraction is not commutative for rational numbers. Subtraction is not commutative for rational numbers. Similarly, you have to check for multiplication. Take two example. Check it whether a into b is equal to b into a. Let a is equal to 2 by 5 and b is equal to 3 by 4. So a into b means 2 by 5 into 3 by 4, which is equal to 2 3s are 6 by 20. To change the positions, b into a, that is 3 by 4 into 2 by 5. 3 2s are 6, 5 4s are 20. Same answer you are getting. That means for multiplication, commutative property is satisfied, or you can conclude that multiplication is commutative for rational numbers. Next fundamental operation is division. Division, if a by b is equal to b by a, then you can say that division is commutative for rational numbers. We will check it. Let a is equal to 1 by 2 and b is equal to 2 by 3. So a divided by b means 1 by 2 divided by 2 by 3, which is equal to 1 by 2. Division will change to multiplication by taking reciprocal. 3 by 2 equals 1 into 3 3 and 2 into 2 4. It's 3 by 4. Now b divided by a equals, change the position, 2 by 3 divided by 1 by 2, that is 2 by 3 into 1 by 2 by 1. Take the reciprocal. 1 by 2's reciprocal is 2 by 1. So 2 2's are 4, 3 1's are 3. Obviously 3 by 4 is not equal to 4 by 3. That means a by b is not equal to b by a. So we can conclude that division is not commutative for rational numbers. So division is not commutative for rational numbers. So for commutative property, addition is commutative, subtraction is not commutative, multiplication is commutative, and division is not commutative. Next property is, third property, associative property. Associative property is bracket change. So 3 rational numbers you have to take. Let a, b, c are 3 rational numbers, belongs to Q rational numbers. Then a plus b plus c is equal to a plus b. See the bracket change. Here bracket inside is b and c. Here inside the bracket a and b plus c. If this satisfies left hand side and right hand side, both the answers if you are getting same, then you can say that associative property is true for addition of rational numbers. Similarly, for subtraction, multiplication and division. We will check it one by one. First for addition. We will take one example. Let a is equal to 1 by 4, b is equal to 2 by 4 and c is equal to 3 by 4. Left hand side a plus b plus c inside the bracket. So that means 1 by 4 plus 2 by 4 plus 3 by 4 inside the bracket. So whenever any numbers are inside the bracket, that calculation you have to do first. So that means 1 by 4 plus, since the denominators are same, 4 you can write, 3 plus 2, 5. Here again denominators are same. So 1 plus 5, 6. So answer is 6 by 4, left hand side answer. Now we will take the right hand side. Bracket you have to change it. A plus b inside the bracket plus c, which is equal to a is 1 by 4 plus b is 2 by 4 inside the bracket plus c is 3 by 4. That is 4, 1 plus 2, 3 plus 3 by 4, which is again 6 by 4. Since both the left hand side and right hand side are same, so you can conclude that addition is associative for rational numbers. Addition is associative for rational numbers. Next comes subtraction. Subtraction also we have to check it similar way. We can take the same example. We have to check a minus b minus c inside the bracket equals a minus b minus c. If these both satisfies, we can say that subtraction is associative for rational numbers. Same example numbers you can select 1 by 4 minus 2 by 4 minus 3 by 4. Left hand side, that is 1 by 4 minus, inside the bracket it is 2 by 4 minus 3 by 4. Same denominator, 2 minus 3, that is negative 1. So 1 by 4 minus negative 1 by 4. You can put inside the bracket this one. So minus and minus it will change to plus. So 1 by 4 plus 1 by 4, which is 2 by 4. Now right hand side we will see 1 by 4 minus 2 by 4, inside the bracket minus 3 by 4. So first inside the bracket you have to do 1 minus 2, it is again negative number, minus 1 by 4 minus 3 by 4. Subtraction of integers, change the sign and symbol. So minus 1 by 4 minus will change to plus negative 3 by 4. This you have learned in 7th standard. So minus, both are same sign, you should add it. So minus 1 plus minus 3, it is minus 4 by 4, which is equal to minus 1. So 2 by 4 and minus 1, they are different. That means subtraction is not associative. You can conclude that subtraction is not associative. Subtraction is not associative. Next comes multiplication. So if a into b into c equals a into b into c, if this satisfies, we can say that multiplication is associative. Take the same example, 1 by 4 into 2 by 4 into 3 by 4 equals, first inside the bracket you have to do, that is 1 by 4 into 2 3s are 6 by 4 4s are 16. When multiplication comes, denominator you have to multiply. So that is equal to 1 6 are 6 by 16 4s are 64. So 6 by 64. Now right hand side we will see, change the bracket. 1 by 4 into 2 by 4 inside the bracket into 3 by 4. So 1 2s are 2 by 4 4s are 16 into 3 by 4. 2 3s are 6 by 64. Same answer you got. That means left hand side and right hand side both are equal, which concludes multiplication is associative for rational numbers. Next comes division. Division, if a divided by b divided by c equals a divided by b divided by c, if at left hand side and right hand side both are equal, we can conclude that division also is associative. So you have to check that. So 1 by 4, we have taken a as 1 by 4, b as 2 by 4 and c as 3 by 4 for easiness. Divided by 2 by 4 divided by 3 by 4, left hand side. So that is 1 by 4 divided by 2 by 4 into 3 by 4, we have to change it as 4 by 3. Take the reciprocal and multiply. Equals 1 by 4. This is 2 4s are 16 and 4 3s are 12. Or you can cancel this 4. So 2 by 3. Here again you have to change to multiplication and take the reciprocal. 2 by 3 will change to 3 by 2. Our answer is 3 by 8. Now we will check the right hand side. A is 1 by 4 divided by 2 by 4 in bracket divided by 3 by 4, which is equal to, first do the bracket, that is 1 by 4 into, change the division to multiplication, take the reciprocal. Here also for division you can multiply it, take the reciprocal, that is 3 by 4 will change to 4 by 3. That is equal to, this 4 and 4 you can cancel, so 1 by 2 into 4 by 3, which is equal to 1 4s are 4 by 3 2s are 6. So here 3 by 8 and here 4 by 6, which are different. Since left hand side and right hand side are different, you can conclude that division is not associative for rational numbers. So addition is associative, subtraction is not associative, multiplication is associative, and division is not associative. Next property is identity element for addition. If 0 is added to any rational number, we will get the same rational number as the answer. Any number, let A be any rational number, A plus 0 equals A only, or 0 plus A equals A only. If you add 0 with any rational number or natural number or whole number, any number also, you will get back the same number. So this is a speciality of 0. So 0 is called the identity element of addition. 0 is called additive identity also. Zero is the identity element for addition, or 0 can be called as additive identity. Similar way, in multiplication, identity element for multiplication. Can you say that which number is identity element for multiplication? The number 1 is having the speciality. If any number multiplies with 1 or 1 is multiplied with any number, we will get back the same number. 1 5s are 5 only. 5 into 1 also is 5 only. So the speciality of that 1, we will call that identity element of multiplication as 1. So 1 is called identity element for multiplication or multiplicative identity. 1 is called the multiplicative identity. So 0 is called the additive identity and 1 is called the multiplicative identity. Next is additive inverse. Additive inverse, you can call it as negative of a number. A number when added to a given number, the answer is 0, then that number is called negative of that number. For example, if A is a number, if you add minus A with this, A plus negative A, or it will change to A minus A, you will get back 0. 0 is the identity element of addition. So if you are getting two numbers when you will add, you are getting identity element for addition, then A is called the additive inverse of minus A and minus A is called the additive inverse of A, or you can call it as a negative of a number. For example, 5. 5's negative is minus 5, or you can say that additive inverse of 5 is negative 5, additive inverse of negative 5 is positive 5. Change the sign and write. That is called additive inverse. For rational numbers, if you take 2 by 3, what is the negative of that number or additive inverse of that number? Minus 2 by 3. What is the additive inverse of minus 5 by 7? It is positive 5 by 7. You have to change the sign and write. So in general, if A is a rational number, then minus a will be the additive inverse or negative of a number. And one note is that here 0 is the number which doesn't have additive inverse. 0 is the only number which doesn't have additive inverse. That you have to remember. It's a note. Next is reciprocal of a number. You have already learned about reciprocal. Reciprocal means you have to change the numerator to denominator and denominator to numerator. A number which when multiplied with another number gives 1. Answer 1. 1 is the multiplicative identity. Then that number you can call it as reciprocal. For example, if x is a number, x is multiplied by 1 by x, which is the reciprocal. X reciprocal is 1 by x. Just take the numerator as denominator and denominator as numerator. You can cancel this. You will get 1 as answer. If you are getting like that, means x is the reciprocal of 1 by x and 1 by x is the reciprocal of x. Any number, if you change that numerator and denominator, then you will get the reciprocal or multiplicative inverse. You can call it as multiplicative inverse also. Multiplicative inverse of the number. So here also 0 does not have any reciprocal, and 1 and minus 1, 0 doesn't have any reciprocal, no reciprocal. And 1 and minus 1 are the two numbers whose reciprocals are same. 1's reciprocal, it is 1 by 1 only, same only. Minus 1, that is 1 by minus 1, which is same as minus 1 by 1 only or minus 1 only. So 1 and minus 1 are two numbers whose reciprocals are same. So 0 doesn't have any reciprocal and 1 and minus 1 are the numbers which have same reciprocals. Now exercise 1.1. First one, write the additive inverse of each of the following. Additive inverse means you have to change the sign. Only sign you have to change. You should not change the number. So 2 by 8, it will become minus 2 by 8. Minus 5 by 9, it will become 5 by 9. This is negative by negative. Actually, it is 6 by 5. So the answer will come minus 6 by 5. 2 by minus 9 means negative will be always top only. So minus 2 by 9, its additive inverse is 2 by 9. This is also same only. These all sums you can do it as assignment. Find the multiplicative inverse. Multiplicative inverse means you have to take the reciprocal. Sign will not change, but number will change to reciprocal. Minus 13 means minus 1 by 13. Minus 13 by 19 means 19 by minus 19 by 13. Negative sign you have to put. 1 by 5 means it is 5 by 1 or 5 you can write. This you multiply it and take the multiplicative inverse. This also multiply it and take the multiplicative inverse. Minus 1 multiplicative inverse is same only. I have already told 1 and minus 1 both the numbers multiplicative inverse are same. Next one is name the property. Minus 4 by 5 into 1 equals 1 into 4. Minus 4 by 5 equals minus 4 by 5. Multiplication with 1, that is multiplicative identity. This is minus 13 by 7 into minus 2 by 7 equals minus 2 by 7 into minus 13 by 17. Order is changed. Order change means it is commutative property. Next one, minus 19 by 29 into 29 by minus 19 equals 1. Answer 1 you are getting. That means they are multiplied with the reciprocals or This is multiplicative inverse. Next one, multiply 6 by 13 by the reciprocal of minus 7 by 16. Take the reciprocal and multiply it. Next, tell what property allows you to compute 1 by 3 into, in bracket, 6 into 4 by 3 as 1 by 3 into 6 in bracket into 4 by 3. Here bracket is changed. Bracket change means which property? Find out. Thank you, children.